right. Jeez, I am. Oh, jeez, I am sweating. Wow. Oh, wow. Um, can I read the? Yeah. Okay. All right. Um. Wait, should I do it like that? Um. That's not. That's somehow set. Oh. So. Alright. Alright. Hello, person who is here and decided to show up. What this is basically I have a physics exam tomorrow, and I thought I might as well get some subscribers off of it, so that's how I'm here today. What I do need is a pen, which I'm not sure if I have it. Yeah, I have here. So I have a few revision questions, and we're gonna be going over them in this live stream. All right. Oof. The diagram shows the horizontal forces acting on the truck. Give the resultant horizontal forces. Oof. Um. Oof. Okay, so basically, here there is a diagram for question 1, right? Hold on, let me just flip this so y'all can see. So basically, here is like a diagram, right? It says here that it shows the horizontal forces acting on the truck. And uh, now we are supposed to give the horizontal force acting on the truck. So in one direction, it says the driving force is 16 kilonewtons, right? And the total resistive force acting on the truck is 16 kilonewtons. Wait. Hold on, is there like a marking scheme for this? Hold on, wait. That's not the right one. Alright, yeah. So, okay, I was confused for a sec because the numbers were the same. But, yeah, so, in one direction, it said that the resistive force that was acting on the truck was 16 kilonewtons, and the driving force of the truck was 16 kilonewtons. So, what we basically do is we do 16 minus 16, which gives us 0 kilonewtons. Uh, yeah, seems simple enough. Okay. The driver of the truck has to stop because a tree has fallen on the road. The thinking distance of the driver. Okay. So, here we have to calculate the stopping distance. It says here that the thinking distance is 7 meters and the braking distance is 20 meters. So the formula here that we'd want to use is the one for stopping distance, which is thinking plus braking distance, right? So as you may have guessed, that is 27 meters. All right. So next question. It says give two factors that would affect the braking distance of the truck. So there are actually quite a lot, but I don't know, from the top of my head, maybe like an icy road. Uh icy road. Right, that is a good one. And another one would be I don't know, probably like drug usage. Like, cause if the person driving would be on drugs, then that would obviously affect the thinking distance of the person. So that's why my second point would be. I mean, I wouldn't say literally drug usage because that would just, I don't know. So maybe alcohol. I'm gonna put alcohol, right? So, um, two factors that would affect the braking distance of the, well, okay, I didn't really think this through. Um, if we're talking about braking distance, not thinking, right? Let's see what the mark scheme says. Uh, condition of the brakes or tires of the road. Well, we said an icy road, so I guess that would fall under the category or uh of like condition of the, yeah. It says here allow wet slash icy. Okay, so maybe like um I'm gonna put condition of the brakes because I don't know why not. They're honestly all equally as good, but the thing I'm gonna put condition of the road. Okay, so here it's a multiple choice question, right? It says which of these factors would decrease the driver's thinking distance? Uh, the choices, I'm gonna show you the choices. Okay. So the choices are the road is dry rather than wet. The truck has all the worn tires rather than new ones. The driver is tired. The truck is traveling at a lower speed. So, here it's talking specifically about thinking distance. So, the which would mean that here the question is basically talking about like which factor would affect the thinking distance. So what I'm gonna put is that the driver is tired because that's the point here that's the most relevant out of these. All right. So my answer is C. Oh, my headphones. Okay. Next question. Uh, Diagram 1 shows the poles of two strong bar magnets being held close together. There is a uniform magnetic field between the poles of the bar magnets. Complete the diagram by drawing magnetic field lines to show that. Right. So, this is what the question looks like, right? It's showing the poles of two strong bar magnets being held close together, right? And what it's asking us to do is complete the diagram by drawing magnetic field lines to show the uniform magnetic field, right? So, okay. So what I'm gonna uh what I'm gonna put is uh two arrows facing each other, cause like um because that right, what I'm gonna say wouldn't necessarily be the correct answer to the question, but here's how I interpret it. Okay, so basically um the two magnets have their own magnetic forces that act in one direction. Okay, so that would mean that if the magnets act in the direction, um, I honestly don't know. I'm just too tired to do physics. Okay, so right, let me just label the diagram first, and I'm gonna show you what I put. Right, okay. So, um, what I put for that question, right? This is how I labeled the diagram, okay? Because the two magnets here are like giving away the energy, right? So, I don't know, that's how I interpret it, but it may not necessarily be the correct answer here. All right. So, all right. Next question. Diagram 2 shows a strong magnet att- attracting an iron block, right? The iron block becomes magnetized when it is in the magnetic field, right? Label the magnetic poles on the magnetized iron block in the diagram that they gave us, right? Um, so, uh, right, so this is what the question looks like. Ideally, I'm not really that great at questions like these, because yes, I am great at like drawing graphs and such, but that's about it. Uh, let's look at the marking scheme. Uh, uh, right. So north, north drawn at the top. Hmm. Oh, wait. Okay. So, um, here's how, here's how I would do this question, right? I just had a little look at the marking scheme. So, the question over here is asking us to label this diagram with the north and south labels, right? And for it to work, we would need uh, the north one over here and the south one over here, right? Because um, if the two forces would act in the same direction, they would push each other away. So, because here in this question we don't really want that to happen, we would need the north and south facing the opposite direction. So, this is how I would do that question, right? Well, I mean, not how I would have done it, but this is what the marketing says on how you would do that question. Okay, so a student takes the strong magnet away from the iron block, right? The student suggests they can permanently use the iron block to attract small pieces of iron. Explain whether the student's suggestion is correct. Um, well, I mean, here, for this question, basically what's going on in the question, right? So, the student is claiming that they could permanently use the iron block to attract small pieces of iron, and they want us to explain whether his statement is correct. Okay, so my answer is no, because from like time, as time passes, the magnets would just sort of lose its. I mean, I don't want to say magnetism, but that's the only word I could come up with. So, what I'm gonna write here as the answer is no, because um the magnet would lose its. What does it say? I mean, the marking scheme says no, because the iron will lose its magnetism, or because iron is a magnetically soft material. Um, I don't know. I am gonna put cause I already started writing in pen. I'm gonna write no because the magnet would lose its magnetism. It sounds dumb, I know, but alright. Okay, so okay. Electricity. Uh, moving on to electrical circuits. All right. So, what the question here is saying, um, the table shows the circuit symbols for some electrical components, and it wants us to complete the table by taking um by by taking which component could visibly indicate the presence of the current. So here is what uh here are the symbols over here. Okay, so um uh I need to work on my symbols, don't I? I know what I do know though is this one over here is the symbol of a light bulb, probably. So uh this is probably one that indicates the presence of a current, because why not, I guess. I also know this is an ammeter because of the A thing, but I'm not sure if it indicates whether a current is present though. Uh, right, so I don't know, chat. Let me look at the mark scheme real quick. So yeah, so one of them was the ammeter, the symbol for ammeter. And second one, uh wait, yo, I just got a new chat. Wait, Ilya, is that you? Cause I remember uh on Monday this week, I think I skipped some of your messages. So let me know if that's you, and I'll give you a shout out. Okay, so back to the questions. So it said that it's the light bulb, the ammeter, and this one here, which I'm not sure what that's the symbol of. Uh, no, it's not. However, whoever. Okay. Um. All right. So. All right. McFlirtien. Interesting name. Shout out to you, I guess. Thanks for coming. And yeah. Back to the question. Hold on. Let me get my phone to search it up. Uh. Uh. Circuit. Right. Alright. Okay. It's kind of it's because it's kind of hard to Wait, hold on. Let me ask ChatGPT. Okay, yes, I know I'm desperate at this point. I am desperate to understand what this one is. Right, so, hey ChatGPT, what is the symbol equation that's in the middle of the image? Shit, I didn't go through. Wait. Um, Hey ChatGPT, what is the symbol in the middle of the image? Right. What is the symbol in the right? Oh well, he responds. I did see. Sorry, I spelled my nickname wrong. It's supposed to be McFlurry 1999. I missed it. Okay. McFlurry 1999. If that's how you pronounce it, then sure. Okay, so ChatGPT says that um so from what ChatGPT said, this one here is a LED light. So yeah, okay. Okay, moving on to the next question. Right. The graph is right. So, uh, what question is it? 3BI. 3B1, I think. In um. So this question right here. Give the name of component X. I'm pretty sure this is a battery. From what I remember. Wait, I think I saw this on when I searched the stuff up. Uh, Hold on, alright, bear with me. Okay, bear with me. Alright, oh no, it's a resistor. Okay, it's a resistor. Resistor. Alright, McFlurrian said, gotta go now. Nice singing though. Alright, thanks for joining the live. I appreciate you. Alright, alright. Using the graph, determine the resistance of component X when its temperature is 50 degrees. Okay. So, when the temperature is wait, hold on. Yeah, when the temperature is 50 degrees, right? So it's right in the middle here, right? So it should be somewhere here. All right. So if we just go here, it should be like 80 volts. I don't know, whatever resistance is measured in, whatever it is, there's 80 of it. Okay. Sorry, I don't know the name of the units, but yeah. So the cell in the diagram 1, right? So the cell at the start of the question uh, has a voltage of 9 volts, right? Um, so this is the question, right? So we know the formula they gave it to us here. So we know that the voltage is 9 volts, right? So we don't know the current, right? And the resistance, so for the resistance, it says when the temperature is 50 degrees. And now, when we look at the graph they did, from the last question, it said we figured out that at a temperature of 50 degrees, Pavlinka, Sia, I did read your message. Okay, so at a temperature of 50 degrees, the resistance is 80. So this is what the resistance is, right? 80 ohms, I think it was. Whatever, however you would pronounce the units, right? So, after doing a bit of rearranging here, you would type into your calculator. For me, it's gonna be my phone because I don't have my calculator with me, right? So you would do 9 volts over the 80 ohms, whatever the unit, however the units would be pronounced, right? Which gives us 0.1125, 0.1125. Alright, this is what I got for my calculation. So, so my current is 0.1125 without rounding it up to any decimal places because they didn't ask us to. And if the answer is small enough, then I'm gonna write all of it, okay? Because it's more accurate. So, to be fair, I am pretty hungry. I don't know. Should I continue? All right. We'll do this last question, and I'm gonna end the live stream because, to be fair, I am craving food. Okay, I am craving pancakes. Okay, okay. So the circuit in the diagram is modified by adding a second identical component in series with the other components. The temperature of the first component and second are reduced to 26 degrees. Explain how the resistance of the circuit is affected by these changes. So, if, logically speaking, okay, if the resistance, if there would be two resistors or whatever they're called, resistors. If there would be two resistors instead of one, that would double the amount of resistance carried around this. Okay, it would be easier if I just show you guys. Okay, so this is the resistor we're talking about, right? Say we add like another resistor X here, right? Ideally, if in the question it told us that the temperatures were reduced to 26, right? That would mean that in the second one, it would be 26 degrees Celsius. And in this one, it would also be 26 degrees Celsius, right? Now, ideally, what that means is that if we transfer the 26 degrees that was set in the question, right? Then that would mean that I would have twice the resistance I had initially, okay? Well, I would have had initially if I started with 26 degrees Celsius and only one of the resistors, okay? So, I don't know whether that would get you the mark. Yeah, in the marking scheme, it says that, yeah, ideally, there would be, Omar, sorry, I don't know how to pronounce your name. Yes, that is from Edexcel, yes. So yeah, basically my point here, uh, it's okay. Thank you, thank you. I got it printed from like Edexcel a couple hours ago, I think. Is it okay if I am Cambridge? It depends, cause uh, we are covering topic 1, 2, and 4, I think. We don't have 3 in the test tomorrow. So we have forces and motion in there, right? Wait, where's topic 2? Sorry. We have forces and motion. We have electricity. And we have solids, liquids, and gases. Okay, those are the 3 that we have. All right, so I don't know. Here I have the everything that I am covering here, right? These are the topics that ideally should be on the Edexcel worksheet, right? Yeah. So basically, if that's what you're looking for, then you're more than welcome to stay here, right? So let's get back to the questions. Okay. Uh. I put if there would be 2 the amount of resistance would increase. Right. Resistance would increase. Okay. So, it says for the second mark, right. So for the second mark, it says that uh, you're meant to have the idea that two components in the series have double the resistance. For physics, honestly, I like physics, but honestly, only the calculations part. Honestly, I am bad at literally anything that is in calculations here. Okay, so right. Um, Here is the full question we just did. Right, this is what I put here. Okay, if y'all want, do take a screenshot now, but either way though, it will still stay up on YouTube because I like to upload my live streams on there. So, thank y'all for joining. Thank you for being here, and hopefully y'all learned something today. And I will see you in my next live stream. Bye.